Now that Tesla's full self-driving end-to-end neural net version 12 has been out for a few weeks, at least to some beta testers, we've been seeing a number of edge cases that previous versions have been able to tackle that version 12 is now able to do on its own. Today, we're going to watch video of James Douma, a leading machine learning expert, take a version 12 drive with Bradford Ferguson of financial investment firm Rebellion Air. James helps explain better than most of us what V12 is doing and why. We're going to review some of his ideas on how to improve FSD and why it can run quite well on old hardware. We've got Hans Nelson joining us. Hans has his own YouTube channel called Hans C. Nelson. Welcome.
Thanks for having me, Herbert.
So this is a fun one. It's one that we've been waiting for, which is James Dauma's commentary, his view of version 12. James is well known in the community, Tesla community. He's actually communicates back and forth sometimes with Elon Musk himself, who understands James' expertise. So he's a machine learning expert, and he can explain to us, a little bit more what he's seeing. So this is Rebellion Air. This is Bradford Ferguson. He's took James on a ride on his version 12 car that has it, and he wanted to see how does version 12 compare to version 11 in tricky spots near Pasadena, California, where James lives near. So let's watch this video. It's about a 3-minute video, and watch James and listen to him, and then you can give us your explanation of what he's saying.
Go over the line.
Very nice. Look at that.
Yeah. Waited for that other car. It slowed down.
So actually, V11 crosses the line in that situation, but it goes much farther across the line. Like this 12 is much more human. Humans will not cross the line more than they need to. So this is always an interesting situation, and that was really smoothly handled. 11 will get to that stop sign, see the truck. That guy's truck is always parked there. And then get kind of confused because it's not sure if it's not totally clear if it's stopped or parked because of the place that it's at. So it'll be kind of jerky a little while, then it'll decide it's parked, finish the turn. That was really nice pedestrian handling. There wasn't any hesitation there. So this is only 1 lane wide. This is a section of road where, you have to stop at one end or the other.
That's cool.
Okay, let's see how it handles this pedestrian. Oh, that was super nice. So this is people like walking up this road. It's really common to encounter pedestrians in that narrow section. And 11 will stop and wait for the pedestrian to clear the roadway before it'll proceed, which is kind of unnatural and the pedestrians don't expect it. So this is where you kind of get the splits. See, it didn't stop and wait to see. And it doesn't always stop there.
Okay.
Okay, so
normally James was saying that he splits, it would stop. So we'll see how it does on the rest of the splits.
So 11, when it sees that motorcycle, it pauses to make sure, because it looks like it's about to pull out
cross
into the
traffic.
road. So there's the amount of hesitation it's almost completely gone. Like it's radically reduced. So this is a place where 11 stops to look as if it's an intersection. 12 doesn't.
This is we're on the main through area of these Y intersections, so it's just
going up to the end of this cul-de-sac.
And would it jitter too when it would stop, or it just come to a full stop?
Occasionally it'll jitter. This is like qualitatively different than 11 is on this road. Okay, so what it just did here is what 11 does at every single one of these, except 11 will stop longer. It'll come to a complete stop.
Complete stop. This only went down to 7 miles an hour.
Yeah. And so for 12, on that particular Y, you can't actually see up the road. So it makes sense for 12 to slow down. Yeah.
Wow, Hans, that was a great clip. Yep. This is James' regular area, very windy, very tight. And it was pretty amazing that all these scenarios happen and just on cue. Like there's at least 5 or 6 that he said that, this is what version 11 would do. And it was able to handle it really well. There's parts where you thought that the car should have slowed down because it was like, there was that one where the pedestrian with the dog, but there wasn't a sidewalk. There was like, the cement, the dividers there, and he's literally on the street, but the car knew to go around it and keep moving instead of just, going, what's going on? And then there's all these construction signs everywhere, and, just before the stop sign, and yet that's nothing. I'm just going to keep going. That's brilliant. What did you get out of that?
Yeah, I love this clip because, James is someone that I follow very closely in his tracking of FSD because, like you said, he's very deep into this space, very knowledgeable about how software is developed in general, but also how machine learning software works specifically. And he's been testing FSD extensively, since the first began really in the days of autopilot. And so he's very familiar with how version 11 operates from both a technical standpoint, but then also experientially. He drives around these roads a lot, and just to see, okay, how is it doing? What are the things that it's good at? Where does it struggle? And so this drive, where in the space of a couple of minutes, we just over and over and over again hear him explain the differences between how 11 would behave in that situation and how 12 behaves in that situation. And in every single instance, the way that 12 is behaving is significantly better than the way that version 11 was behaving. And so, just once again, reinforcing that version 12 really is a step change in functionality that is just in one shot, just eliminating numerous edge cases that version 11 struggled with and really didn't even necessarily have a good pathway to ever fully solve. And so this is a great demonstration of the progress. And to just put into context for people, that version 11 was really the culmination of 6 to 7 years worth of effort on this software 1.0, kind of mixed then towards the end with software 2.0, but this hybrid system of using human written code and machine learning code to figure out how to drive like a human would. And now version 12 is the first version that is fully just machine learning neural networks that are taking the information from outside the vehicle in through sensors and then putting out the actions. And there's no lines of C++ anywhere in there that are saying, okay, if you see the situation, do that. And so this shift in this migration to version 12 end-to-end neural nets is a huge step forward. And we've made that shift. Like version 12, the development of that really began about a year ago. And so we're seeing a step change in functionality that they were able to achieve with 1 year's worth of work that surpasses the work that they did for 7 years in this hybrid system. And so the implications of that moving forward are incredibly positive for, we had really slowed down, and it was a question, can we actually solve all the edge cases or not if we continue down this road? And now we're seeing so many edge cases solved all in one shot that we say, okay, I don't know if we can make it all the way there from where we're at today, but we at least know that we're going to continue to make a lot of progress for the foreseeable future. And we'll see if we drive into one of those cul-de-sacs where, from a metaphorical standpoint, where it seems like we're not going to make any more progress down this road. We're going to have to turn around and go back to a previous intersection and figure out, okay, what's the right way to go? But right now it looks like we're, cruising towards the finish line.
Too many metaphors. It's too many metaphors there. Thank you. Good job. But yeah, so James himself has said that it's qualitatively better. And you can actually see that it drives so much more like a human, like you were saying. That's the critical thing. At this point, it's looking like, let's cross our fingers, right? It's looking like version 12 is going to be able to continue to learn, because it's learning on its own. So it's almost like, what could be the rate limiting step? What could be the local maximum of learning? Because it seems to be able to learn. If you can learn, what is it that it won't be able to learn?
Well, and the reason why we need to build out this massive infrastructure of NVIDIA GPUs and Dojo GPUs or, Dojo chips is that we are learning, like we're able to learn. We're just not learning as fast as we would like to. It takes us a long time between iterations and steps because we don't have enough compute today. And then as we get that solved and we can learn faster, then we get to explore more and more areas and figure out what is the exact right architecture, what is the exact right, code base to do this. And we're moving fast in that direction.
Yeah. So not just Elon, but a number of the Tesla FSD developers have said that we're compute constrained. If we build out the data centers, then we can feed it videos, and you need to feed it millions of videos of good driving. And so if there is an edge case of somehow this version 12 is not solving, then they will just feed it videos of that edge case until it learns it and figures it out. And again, more videos, more data centers. So that's where we're at. So let's listen a little bit more to a post that James Douma posted on X, and he's talking about how to improve FSD. Okay, so he says, I've been asked a few times about how and whether FSD can continue to get better without improvements to the hardware. So what we're talking about here is the hardware that's sitting in the car. Because one of the unique things, and people don't give Tesla this credit, is that we are developing autonomy with such few hardware on the cars, but it's retroactive to all the cars, and maybe not all the cars, but even hardware 3 cars that's been in the roads for years, it can still work. And so this is the cool thing, the hardware that's sitting in the cars. This question is often asked in the context of a misunderstanding of how neural network optimization and improvement generally works. I'm going to take a minute here to explain it. It's a very long post, so I didn't cut all of it out. Maybe you can summarize what he did say.
Yeah, and so this is really a response to people who say, sure, even if Tesla can develop full self-driving and it is capable of becoming level 3 or level 4 or whatever level, that system will not be able to be backwards compatible with hardware 3 cars. And so that Tesla will only be able to have that functionality on cars that are produced in the future. And that has a big difference on what someone might value Tesla as, because if you can have that software that's incredibly valuable and you can ship it to every car in the fleet, that creates one set of financials versus if you can only ship it with cars that are new off the line moving forward from that point in time. And James's point throughout the post is that it's such early days right now in the development of machine learning, and that we really don't know very well how to build these things in the most resource efficient way so that they can get the most performance on the least amount of hardware resources. And that he goes through a whole list of different areas where there's lots of room to optimize the performance of these things. And just a good analogy that people can use to think about is we're seeing these large language models be developed first, by someone like OpenAI, and then there will be an open source version of it that's released shortly thereafter, not that long, maybe 6 months or so. And that once those open source models are available, and these are huge models, they can be compressed, shrunk down, and people can run them on a laptop. And so you're talking about something that when it's initially developed by the research community, it has to be run on large data center hardware. And within a year, something that gets 80 to 90% of that level of performance can be run on someone's laptop. And that is just an example that shows the ability of us to translate incredible research breakthroughs that are incredibly resource intensive and you would think might require specialized hardware in order to run. And you can, over time, and it's not even that much time, it's just really all optimizations in software that they can take that and run it on something very small. And so the same thing is going to be applicable to hardware 3, that it should be, by all intents and purposes, capable of running whatever future versions of FSD, as long as we have the sensor suite in place that we need, which it seems like it should be pretty good. And if that's the case, then people ask the question, okay, well, if hardware 3 is enough, why does Tesla continue to make new versions of the hardware? Why do we even have hardware 4 if hardware 3 is enough? And James then goes on to explain that these chip companies are constantly, who are manufacturing the hardware 3 computers, they're constantly updating the way that they make chips and the architecture that they use. And so every couple of years, they're going to have a new way to make chips. And when they're updating their ways, you'd like to go ahead and say, hey, I want to, continue to upgrade the architecture that you're building for me on top of whatever the latest and greatest is that you're doing for everyone else, because the reason that they're upgrading is that costs are cheaper for the same amount of performance and energy usage is less. And so there's no reason for Tesla not to continue to update hardware 3, hardware 4, hardware 5 at the same time that TSMC or whoever it is that's making these chips is upgrading their overall architecture. But that doesn't necessarily mean that those previous versions won't be compatible with future versions of software.
Yeah. This is thank you for explaining that, and thank you for James for explaining that. Right, you need incredible compute on a data center side to teach and train the AI, the neural net, to allow it to learn on its own. But when the actual car itself or the edge device is doing it, it doesn't need that amount. But what's critical is how low the power usage is required on the edge device, in this case, the cars. And one of the things that's, again, underappreciated is Tesla's chips that they have in the car is so optimized for low latency, low power, to be able to handle the decision making at such a quick speed without taking a lot. And that's one of the reasons why they can do this at such low prices. And it's mind boggling to realize what Tesla's accomplished here, or is about to accomplish, which is backward compatible to all the cars. Such very few low cost cameras, 8 cameras around the car, that's it. No LiDAR, no expensive gear, none of that thing. And then the chips that they've been placing in the cars is enough. So let's continue with what James is saying. I think you've repeated a few already, what he said, but he says this: with Tesla's continuous improvement process, they would naturally want to periodically upgrade to a newer platform as better capabilities become cheaper. It's dumb to not take advantage of Silicon Foundry improvements. So we have hardware 4. Eventually, there will be versions of FSD that offer better functionality on hardware 4 than on hardware 3. But the additional capabilities of hardware 4 aren't needed yet, and probably won't be for some time. So hardware 3, it's optimized for that, and it'll be just fine to run full self-driving. There will be hardware 5, 6, and 7, just as we're on iPhone 15 now, and there's no end in sight. FSD will be no different, because we are very, very far away from done with making AI, computers, or cars better. As for AI, we haven't finished picking up the fruit that's lying on the ground, to say nothing of the vast amount of stuff that is low hanging. So that's good news to hear from James, kind of a machine learning expert, to say that hardware 3 is good, but of course there's going to be improvements further.
Well, and one of the other points that he made a little bit earlier is that there's really one input that you can put into the system to get the benefit of having a complicated piece of software run on smaller hardware resource constraints. And I would actually extend that to a second one that he didn't mention, but that is developer time, that you can invest more developer time to simplify code to run very well on a smaller piece of hardware and use less energy. That's one. But then the other one is, there's also in the machine learning field a known relationship between, if you spend more time training a model, then it requires less resources and therefore less electricity to actually operate that neural net at the inference time. So whether you're running that on a phone, a laptop, or on a car in this instance. And because we are looking at, Tesla, this is one of the reasons I think that Tesla is saying that they are compute constrained, is because they want to front load the complexity of developing these neural nets, doing all of the heavy lifting and actually extending, doing even more than would necessarily be optimal if you had tons of compute in the car. They want to transfer all that complexity into the cloud, do that at training time, and then have the most optimized, most simple, most resource efficient version in the car. And so when you're looking at having a fleet of millions, we've got over 5 million vehicles in the Tesla fleet today. And I don't know how many of those are hardware 3 and above, but even if they don't have 5 million hardware 3 cars and above today, they'll have that shortly. And so if you're looking at that asset, it makes a lot of sense to spend the money necessary to have enough training compute and enough developer time invested in that to then be able to provide this functionality back to those hardware 3 vehicles.
Okay, so that's a lot of good news that we just shared, but there's some not so good news, but it's not as terrible as people think. So let's address that. Looks like that FSD version 12, some people thinking it's delayed because typically they do updates every 2 weeks. But TeslaScope, who is one of the software organizations that has a really good understanding of what's happening. They have software that people download on their Tesla's phone apps, and they're able to see, in quite a number of Teslas, what's happening. So anyways, they reported that there's a delay for the unforeseeable future. They said, due to a specific incident that happened, we'll be publishing more information after 2:30 in the morning if the update hasn't gone out by then. So what does he mean by unforeseeable future? Coffee Table Tesla says, delay for the unforeseeable future sounds way longer than if it was just for the foreseeable future. But TeslaScope said, yeah, everything has its process. We don't expect a major delay, just not going to meet the original scheduled deployment date. So then they explained this a little bit further. Tesla avoids keeping any vehicles enrolled in Wave 1, Tesla's early access program, on a version for over 2 weeks. So they like to kind of keep updating every 2 weeks. Prolonging this testing period defeats the program's purpose to try out and provide feedback on new features before they're released to customers. This is why each of the last 4 FSD updates has been around this 2 weeks schedule. When this period is longer than average, it's typically due to something critical that requires additional testing, and in the case of version 12, model training. So this is what happened. Last week, version 12.2.1 deployment was initially paused due to issues reported with the auto speed modulation, causing unintended uncomfortable maneuvers. I think we saw some of the beta testers report that sometimes the car is doing something a little bit more aggressive than they expected. While no safety critical issues had occurred yet, this had the potential of causing minor incidents, such as being rear-ended, so the update was pulled. Despite this, the internal deployment goal for the next iteration was set to March 1st, which would have been 11 to 12 days later on schedule with prior releases. But a specific incident occurred, a crash. A little under a week after the initial deployment, version 11.2.1 required a full internal investigation. Actually, they made a mistake. That's version 12.1.1. Required a full internal investigation the following day. Nobody was injured. The vehicle experienced minor cosmetic damage. So they call that a crash, but actually it was just a bumper thing. We were made aware this morning that this is the reason for the missed deployment date. The date has yet to be adjusted, so we've not provided a proper update outside of replies. Yeah. What's your thoughts on that, Hans?
Yeah. So it's pretty widely speculated that this is a result of, I think it was maybe AI driver who was doing some testing in a parking lot and did get into a very, very minor fender bender. And it's likely that that is the incident that's being referred to here. I do think this is going to, like TeslaScope said, it's definitely going to delay us a little while. The question is how long, and hopefully it's not that long. It will be something to monitor closely, but the great thing to see in all of this is that the issue that was identified was a minor issue that really didn't cause any safety risk to people, just a property damage risk. And so that's, relatively, it's a lot lower on the totem pole of how bad could this have been than something that, was putting people's lives in danger. So it's an issue. It has to be fixed. They can't be going around crashing into things and causing lots of damage to the Tesla vehicles themselves or the vehicles of others or property. So it is a serious issue. It has to be resolved, but it is not a safety critical issue. And so that part's good news. I think it's likely that they're able to work through this also because it is kind of a minor, like, slow speed thing. Like, whatever this emergent behavior is, I don't think it's something that will be very difficult for the team to fix. And so my expectation for timeline is that, this maybe pushes us around a couple of weeks, maybe a month at most, just because these things are, like, the way that you have to do a retraining run in order to solve the problem could take a little while. But I think that they'll know exactly what needs to be done very quickly, and that we should then be able to build forward from there.
Yeah, thank you for that. So those good news and bad news, and we'll see what happens further. Thank you so much, Hans. Follow him on his YouTube channel, Hans C. Nelson. Thanks, everybody. Bye-bye. I've created a website that is the most comprehensive resource for the Tesla investor. Please check it out. Simply go to my website at herbertong.com.